Hello and welcome back. The following problem states the decomposition of hydrogen peroxide is first order. The rate constant for this reaction at 20 degrees Celsius is 1.8 times 10 to the negative fifth per second. If the starting concentration of hydrogen peroxide is 0.75 molar, determine, in part A, the concentration of hydrogen peroxide remaining after 3 hours, and in part B, how long it will take for the hydrogen peroxide concentration to drop to 0.10 molar. So when approaching this problem, the nice thing about this problem is they already told you it was first order. However, if you did not know it was first order, what you could have looked at was the rate constant. In this case, K is equal to 1.8 times 10 to the negative fifth per second. Per second is the units associated to a first order reaction. So now that we know it's a first order reaction, we know that Ln, or the rate equation for first order reaction, is Ln of your concentration at a specific time, so in this case peroxide, at some time, over peroxide concentration of your initial concentration is equal to that of negative K times T. So when approaching this problem, we are looking for the concentration of hydrogen peroxide after 3 hours has elapsed. But in order to use this expression, we also need to make sure our units are all the same. So our rate constant is in per second, so our time also has to be in seconds. So our time is equal to 3 hours. So we have to convert this to seconds. So we multiply by 60 minutes, or in an hour. And we know there's 60 seconds in a minute. So hour and hour cancels out, minute and minute cancels out. And this is equal to 10,800 seconds. So perfect. Now we have everything in the proper units. We can then rearrange this expression to solve for the concentration of hydrogen peroxide after 3 hours have elapsed. So in order to get rid of the natural log, we put everything to E. And so this then simplifies down to the concentration of hydrogen peroxide at some elapsed time over the concentration of hydrogen peroxide of the initial concentration is equal to E times negative E to the negative KT. Well, we want to solve for hydrogen peroxide at some time, so we multiply both sides by the initial concentration. And then we then get this simplified down to the concentration of hydrogen peroxide at 3 hours is equal to the initial concentration of hydrogen peroxide times E to the negative KT. So what we can go ahead and do, we can plug in all the variables into this expression. And then once we do so, we will end up with a final concentration of 0.62 molar. And that's the first part. In the second part, they're asking us to determine how long it will take for the hydrogen peroxide concentration to drop to 0.10 molar. Well, we're going to be using the same rate expression. However, now we're going to be solving for time. When we rearrange this equation, we will get time is equal to Ln of hydrogen peroxide at some time divided by the initial concentration of hydrogen peroxide, all divided by negative K. Well, once we do that, we can then plug in all the appropriate variables, and this will end up equating to be 1.12 times 10 to the fifth seconds. And we can convert this to hours by doing the same thing that we did before. In 1 minute, there are 60 seconds. In 1 hour, there are 60 minutes. Seconds and seconds, minutes and minutes. And we end up getting this equating to 31 hours. Remember, when you're approaching these problems, it's very important to take note of your rate constant, the units to your rate constant, because that's going to also tell you a little bit more information about what rate order your reaction is following.